Find the sum of the following series. Let us begin. Let's try to understand the series first. We have here the first term, that's 1. It's multiplied to n added to. The second term, here we have 2 multiplied to n minus 1 added to 3 multiplied to n minus 2. And this keeps on going all the way up to the second last term where we have n minus 1 multiplied to 2, and the last term, that's n multiplied to 1. Okay, in order to find the sum, what we'll do, we'll try to find a general term here, or we can say the rth term of the series. So let us suppose that let tr be the rth term of the given series. So here we need to understand, before defining the rth term tr of the series, we have to understand the series, what is happening here. So if we consider only the first digit of each of the terms, so here we see that 1, 2, 3, this goes all the way up to n minus 1, comma n. This is a arithmetic progression. These terms are in arithmetic progression. Then what is the rth term? The rth term is simply going to be r. We're considering the rth term to be equals to r. Then if we consider the second digit of each of the terms, so here starting from n, we have n, then followed by n minus 1, and we have n minus 2, goes all the way up to 3, 2, and 1. Now this sequence is exactly the same as the previous one, with only difference being the terms are written in the reverse order, and also these terms are going to be in arithmetic progression. Now the question comes, what is the rth term of this arithmetic progression? Now to find out the rth term of the second arithmetic progression, we'll have to take an example that will be best understood. So let's say we have an arithmetic progression with 10 terms. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Then we will consider another arithmetic progression, but this time the terms are going to be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now, let's say we want to find out the rth term. So here the condition is that the corresponding terms are multiplied to each other. That means we have 1 multiplied to 10, 2 multiplied to 9, 3 multiplied to 8. Okay, so let's say we want to find out the rth term. So here if we consider the sixth term to be the rth term, then we can say here that the sixth term from the beginning, that's exactly the same as taking the fifth term from the end, because they are corresponding terms. So here we are saying that taking the sixth term from the beginning is exactly the same as the fifth term from the end. So how to define the fifth term from the end? So in total, we know there are 10 terms. Total, there are 10 number of terms here. And from here, we have to subtract, in order to reach the fifth term, we have to subtract the terms that are previous to 5. So that means 1, 2, 3, 4, 5. So there are a total of 5 terms before the fifth term. So 10 minus 5. So that is going to give us total, that's going to give us 5. So that is exactly the fifth term from the end. Okay, now this is what we're trying to do here. So in our case, so we need to find out the rth term of the second sequence. So here we will say that there are total of n number of terms starting from the first term, where we have each term is the product of the two corresponding terms. From here we are going to subtract r minus 1. So that is going to give us the rth term of n minus 1, n minus 2, all the way up to 1. So to find out the rth term of the general tr of the series, what we'll do, we'll take the rth term of the first sequence, which is simply r, and we're going to multiply it to the rth term of the second sequence. So that's going to be n minus r minus 1. So this is going to now give us r multiplied to n minus r added to 1. Taking the product, we have r times n minus r squared added to r. We're going to combine the first and the third term. We have n plus 1 multiplied to r minus r squared. So this is going to be the rth term of the given series. Now in order to find out the sum of the series, so let's call it as, this is simply going to be, take the summation of tr, where r is going to run from 1 to n. Fine. So this is going to be now equals to, so we have summation n plus 1 times r minus r squared, where the index r goes from 1 to n. Now let's expand the summation. Now we have n plus 1, that is simply a constant here, so it will be going to be pulled out of the summation because we're taking the sum over r. So we have summation of r, where r goes from 1 to n, minus summation of r squared with r running from 1 to n. This is going to be equals to n plus 1. Now what is summation of r? Summation of r, that's simply the sum of the first n natural numbers. We have 1 plus 2 plus 3 all the way up to n. Now we have r going from 1 to n, and there's a standard formula for that, that's given by n multiplied to n plus 1 divided by 2, minus, now summation of r squared, that is the sum of the squares up to n natural numbers. So we also have a standard formula for it, given by n times n plus 1 multiplied to 2n plus 1 whole divided by 6. Okay, now what we'll do, we have two terms, we're going to combine n. We're going to take n times n plus 1 over 2 as the common factor. So this gets multiplied to n plus 1 minus 2n plus 1 divided by 3. So we have n multiplied to n plus 1 over 2 multiplied to 3n plus 3 minus 2n minus 1 whole divided by 3. So that's now going to give us, we have n multiplied to n plus 1. So 3n minus 2n, that's simply n. 3 minus 1, that's positive 2. Where n times n plus 1 multiplied to n plus 2 whole divided by 6. So this is going to be the final sum of the given series.